All right, in this video, we are going to go through example 3 from Unit 1. So take a second to read through this question, and then you'll also see the chart that it mentions there. You should have actually used this Census at School website before. Okay, so let's look at the first question here. And the first question asks us, who are the individuals? And then we also want to know if we're looking at things that are discrete or continuous. Okay, so just think back to what those 3 vocab words mean: individuals, discrete, continuous, and then take a minute and see if you can answer this question. The answer that I have is the individuals are students from Australia, Canada, New Zealand, South Africa, and the UK who have taken part of the project. Remember that in statistics, we really like to mimic the wording of the question. So here I see students from, and then all the countries that have taken part of the project. I could have probably included since 2000 as well. So just make sure that you are really mimicking the wording that's already there. We want to be very, very, very specific, not just students, but students from these countries. Okay. And then the question of is it discrete or continuous is going to depend on which variable we're looking at. So let's answer that question after we look at part B. Okay, so which variables were measured? Classify each variable as categorical or quantitative. Again, go ahead and do that. Pause the video and write those down. The variables that I see are just going to be all these categories here. So we're looking at a sample of 10 Canadian students. So we have their province, their gender, the language that they speak, whether they're right or left-handed, height, wrist, and preferred communication. And I went ahead and just wrote them already as categorical and quantitative. Get those out of the way there. So the categorical variables are any of them that relate to a category. For example, province is categories, gender is a category, left or right-handed is a category, and then their preferred type of communication. The quantitative variables are the numbers for which it makes sense to find an average. So that would be, for example, the number of languages that are spoken, their height, and their wrist circumference. Now let's go back to this question about discrete or continuous. And actually, we probably should put this question here anyway. So let's go ahead and answer that. Remember that discrete and continuous only apply to quantitative variables. So we're don't need to categorize the categorical variables, just the quantitative variables. Let's look at language spoken. Language spoken, are we looking at whole numbers or a number that takes any value? For language spoken, you would give a whole number answer. So that one would be discrete. You wouldn't say I speak 1.25 languages. Okay? Even if maybe you took high school Spanish, still doesn't count. Height would be in centimeters. It looks like they've given things as 0.5, but in theory, you could record your height as anything, so we'll call that one continuous. The same goes for wrist circumference, so we will again call that one continuous. Okay? All right, let's look at the next page. Over here, there's just a few questions I want to answer. Question C asks us to describe the individual in the highlighted row. So what we need to do now is go back to our chart and look at the highlighted row. And you need to describe this individual right here in the highlighted row. So take a couple minutes, pause the video, see if you can describe this person. Make sure you include all variables that we did uncover about this person. Okay, so my description, you'll notice I've used complete sentences. Male from Ontario. He speaks 4 languages, is left-handed, and prefers to communicate by text. He is 157.5 centimeters tall and has a wrist circumference of 147 millimeters. So all I've really done here is list out the information, but it is important that you can pull information from a table like this. So while it might seem pretty easy, make sure that you're able to do this and kind of pull information from a chart. Okay, so I do have a question for you. Not really a right answer for part D, but I want you to see if the data makes sense. Because sometimes things will happen, we'll be looking at data, and things will start to look a little weird. And as a statistician, your job is to find the weird data. So let's look at this chart. and see if you can find any data points that might seem a little bit of something odd happening there. I noticed that there's someone who has a 65 millimeter wrist circumference. That seems a little bit odd to me. Odd because no wrists are really 65 millimeters, at least not according to the information that we have here. So I did measure my wrist circumference in millimeters. Mine was like 160 something. So I kind of fall into line with these ones here. 65 millimeters is really, really, really small. So that seems kind of odd. You may have pulled out that this male was left-handed. There's only one left-handed person out of all the right-handed people. But let's think about that one for a second. Is that really odd, or does it align with what we think it should be? Are there not more right-handed people than left-handed people? Yes. So this left-handed, the fact that there's only one left-handed person in a group of 10 is probably not that strange. Okay. Oh, you might have pulled out this person because they like to communicate by Facebook. This data is a little bit dated, obviously. So, I mean, cell phone and text messaging, is there really a difference there? I don't know. Okay. So we can call these oddities just because it's dated information. Okay. So that was example 3, the census at school.